everybody, I'm Beaupre. I am a PhD student at SUNY ESF, the State University of New York, College of Environmental Science and Forestry. And I just feel so privileged to be working on Caribou. I want to thank my co-authors and our funders and our collaborators. It's been really exciting to work with folks who are so committed to caribou conservation, and I am so grateful for our collaboration. This research really wouldn't have been possible without all the wonderful work that everybody's doing. So adult survival is a central driver of barren ground caribou herd populations, which are globally declining. As caribou progress through their annual life cycle, they move around really broad seasonal ranges and experience varying environmental conditions, which has a resulting influence on their survival. And understanding the causes and factors that are associated with low survivorship might help wildlife managers to mitigate impacts to conserve caribou populations. And so we wanted to explore the seasonal patterns of survival and how these patterns have changed over time. And we also wanted to explore how movement behaviors and environmental conditions influence survivorship. And so we focused on the Western Arctic herd, so it's great to be following Matt. I think he had a lot of good previews without too many spoilers for my presentation. So this is a large barren ground caribou herd that ranges throughout Northwest Alaska. And like other large herds, this population naturally undergoes population fluctuations, and right now it is in a decline. The Western Arctic caribou range is roughly bisected by the Kobuk River, which is shown in blue here. And this river flows from east to west, south of the Brooks Range, and drains that large river basin. And historically, the majority of the Western Arctic herd caribou crossed the Kobuk River during their fall migration to reach their wintering grounds south of the river, and then they would migrate across the river again in the spring to reach their calving grounds. And caribou often cross the river at a particular site, which settlers have called Onion Portage. And this site has been a caribou hunting camp for millennia. And so the earliest ancestors of the Inupiat who still live in the Kobuk River Valley have hunted caribou at Onion Portage. And so we'd like to acknowledge that this is a really bountiful place that has been occupied by Inupiat for generations. This land and the caribou have sustained people and their culture, and we really owe the ancestors of the Inupiat and the Inupiat of modern times a debt of land and history. So we want to honor their historic and ongoing contributions to caring for caribou and the land. In addition to its cultural significance, the Onion Portage is where many of the caribou in this study were captured and collared. So from 2009 to 2019, the migration south across the Kobuk River in the fall was reliable enough where we could go down there, drive a skiff alongside the caribou, grab them by the antlers and put a collar on them. However, in more recent years, caribou migrations have been later in the season, and an increasing number of animals are remaining north of the river throughout the winter. And so in 2019, animals were collared using helicopter-based net gunning capture. And we deployed collars on adult females. Collars collected a location every 8 hours, but for our analysis, we just used a daily average location. We determined mortality events by the collar not moving but still working, and when possible, collars were recovered by visiting mortality sites to locate remains. If you're lucky, you might get to a mortality location and find a carcass, but more often than not, this is a very remote study area. It's very vast and hard to get to these places, so you'll get there and you'll look lucky if you find some fur and a spare bone. So once we had all the movement and mortality data in hand, we broke up the annual movements into 6 ecological seasons, and we followed divisions used by other studies for these same animals. And so we had calving, which was what we considered the start of our biological year. There was insect harassment period when Western Arctic herd caribou are almost entirely aggregated on the coast, looking for relief from bugs. There was the late summer period, fall, which encompasses the fall migration and the rut, winter, which is the longest season, and then spring, which includes the bulk of the spring migration period. And these figures, black are the movement trajectories of animals, and the red X's are mortality locations. And there is considerable interannual variability in caribou movements, but these broad seasonal divisions worked well for our study. And we focused our survival analyses on estimating the daily mortality hazard, which is the probability of individual mortality per day as it varied throughout the year. We explored these hazards using those 6 discrete seasons that I just described and fitting parametric survival regression models using the R package survival. And then we also quantified and compared estimates of timing, duration, and intensity of statistically defined seasons of higher mortality using the R package cyclomort. In total, we analyzed 326 adult female caribou. There were 196 animals that died, and 130 were censored, which means the collars dropped off or the caribou were still alive at the time of our analysis. And the overall daily hazard was equivalent to a life expectancy of 2.7 years post-collaring. And then seasonally, the daily hazard varied. Survival was highest during the winter seasons in general, and survival was lowest in the spring. The cyclomort continuous time seasonal analysis, which doesn't depend on those predefined seasons, agreed. There was this higher peak of mortality in the spring, and then it also suggested a second weaker peak of mortality in the late fall. And this could be due to the additive effect of hunting on top of like the rut and fall migration, but the confidence intervals there are overlapping 0, so that estimate is less robust. In the Western Arctic herd, survival rates and patterns have shifted in more recent years, and so we further segmented several of our analyses into 2 time periods using the cutoff of May 28th, 2016, which was the end of the 2015 biological year. So in this figure, early years from 2009 to 2015 are shown in orange, and the more recent years from 2016 to 2021 are shown in purple. And we can see that there are very different patterns of survival between the earlier and the later periods. In the later period, we saw the peak of mortality shift from summer to earlier in the spring, and then that peak of mortality in the spring in the more recent period is also higher. So there's a higher hazard rate in the more recent period. So considering the shift in survival rates and migratory behavior in recent years, we also wanted to explore the survival consequences of crossing or not crossing the Kobuk River. And so these figures show that winter season following fall migration. Before the cutoff is on the left and after the cutoff is on the right. And so first, we assessed whether an individual crossed the Kobuk River in the fall for each biological year that it was monitored. And then we determined whether those animals survived in the following winter and spring. And to evaluate trends and proportions of animals crossing the Kobuk, we fitted logistic regression models with the probability of crossing the river, which was a binomial, as a function of year, and then we used random intercept for individual. And then to further investigate the probability of survival as a function of crossing the river, we looked at the probability of survival as a function of that crossing binomial using the crossing and year as a random effect. So this figure shows the proportion of animals migrating in the top panel, that's shown in beige, and then in the bottom panel is animals that migrated south of the Kobuk in green. And darker colors are animals that died in either of those categories. And you can see just looking at it, but the statistics backed it up that there was a significant increase in proportion of animals that are not crossing the Kobuk River annually. The results from our logistic regression, looking at survival as a function of crossing the river, did not indicate that survival was significantly influenced by crossing the river. The results from that model are shown here. So again, animals that didn't cross south of the Kobuk River are shown in beige, and animals that did migrate south are shown in green. And while there wasn't a significant difference in survival between those two groups, you can see in the figure that there's a lot more variability in the animals that crossed south of the river, while survival for animals that stayed north remained more consistent. And so when we saw these results, we all thought that there was this high risk, high reward behavior associated with the choice of whether or not to cross the Kobuk. But since there aren't significant survival consequences for crossing, we really wanted to know if there were environmental factors that are influencing caribou for whether they're gonna cross the Kobuk River or not. So we collected a suite of environmental covariates from remotely sensed and modeled sources, and then we extracted their values to every caribou location. We used snow depth, daily maximum temperature, wind speed, and that awesome lichen data set. And then we used some of these covariates to investigate why animals might cross the Kobuk River, and others we used for the survival analyses. And so if it's not survival that's driving the decision to cross the Kobuk, what are those environmental conditions that influence caribou to make that choice? So we looked at probability of crossing the river, which is binomial, as a function of environmental covariates averaged across the fall season. And those are experienced environmental conditions because they were extracted at every caribou location. We looked at snow depth, temperature, and wind. And the results from this regression were surprisingly consistent. All three covariates were significant with negative coefficients. So caribou were more likely to cross the Kobuk when there was less snow, less wind, and lower temperatures. And so this figure shows results from that model. The probability of crossing south of the river is on the y-axis as a function of each of those environmental covariates. And you can see by the negative slopes that animals are less likely to go south when it's snowier, warmer, and windier. And so our next question when we saw these results was, are those conditions that lead to less likelihood of crossing south associated with lower survival south of the river? And so we evaluated the probability of survival against environmental covariates for animals that stayed north versus animals that went south. And again, we looked at environmental covariates averaged across fall season and winter season, and we averaged those environmental covariates separately. So we had snow depth in the fall, snow depth in the winter, etc. And then we fit models using each of those environmental covariates as a main effect with a binomial response for survival using year as a random intercept since there's considerable variability between years. And then we included the duration of collar deployment as an additive effect to account for the fact that we don't have animal age information and survival is going to be influenced by age as animals get older. And because the two regions, north and south of the river, are ecologically distinct with varying winter weather patterns, we modeled these effects separately and then looked at the effect sizes of those environmental covariates. So this figure shows the main effect of weather covariates on the probability of survival in winter and spring for animals that wintered north on the left panel and south on the right panel. And significance is reflected in the colors, with gray colors having a p-value greater than 0.05. And so for our question, when we look at snow depth, fall snow is higher south of the Kobuk River. Looking at temperature, when fall temperatures were higher, survival was higher south of the Kobuk. And then looking at winds, when winter winds are higher, survival is also higher south of the Kobuk. So for that question, it kind of looks like when they get south, more snow was indeed linked to lower survival, but for wind and temperature, not so much. And another really interesting result that came out of this analysis was that greater lichen cover had a positive effect on survival south of the Kobuk, which might be the reward in that whole high risk, high reward decision of whether or not to cross the Kobuk, which we got to see in Matt's presentation, which was really cool. So for many temperate ungulates, winters are a survival bottleneck. However, seasonal survival patterns of caribou generally indicate that winter is a period of relatively lower mortality risk. And this was true for the Western Arctic herd. However, in the more recent years, there's been a shift in survival patterns, seasonal patterns of survival, where the peak of mortality has shifted to earlier in the spring, which is less caribou-like and it is more characteristic of other temperate ungulates. And there might be climatic or environmental differences between the two periods to help explain the declines in survival, or there might be some combination of something else entirely, and that is worth us digging into further. There is a decline in animals migrating south of the Kobuk, and this is occurring in tandem with the population decline, but there aren't significant differences in survival between animals that do and don't cross the river. And it's been reported in the literature that this herd has stopped crossing the Kobuk during periods of population decline in the past, and that could be what's happening now. There are a lot of lingering questions, and I have a million more to add to this list after being here for a few days, but some of the ones that are top of mind are additional questions about propensity to migrate that I think are really worth digging into. I'd love to pull out animals that have been monitored for multiple years and look at their like migration choices year after year and see if they're making the same choice or if they're doing different things year after year, and how that influences survival and how those choices are environmentally dependent. Finally, we're interested in comparing the drivers of survival among herds with different population trajectories. There are other herds that are experiencing similar shifts in wintering grounds, and we're really interested in asking these same questions and applying similar methods to those herds and seeing how they compare. Thank you.